Okay, in our second lecture, we're going to talk about the scientific method. We've all familiar with scientific method from the past, probably our previous experiences, but let's review it one more time to get sort of a common foundation about what I'm referring to as the scientific method. This is the cyclical process we use to understand the world around us. So the very heart of this scientific method is making observations. So we want to make good, detailed observations about the world around us. Based on those observations and the phenomenon we're witnessing, we always ask questions. So based on these observations we don't understand something, we ask a question. Within that question, we're trying to understand that observations we have. In order to understand it, we sort of create a model. So the second step is we always propose a model. Some way to explain those observations. Some simple conceptual understanding of the process that we think is occurring to explain the observations that we're observing. Within that proposed model, we have to have a small piece that we can test. We always think of this as the hypothesis. It's a testable explanation to explain some small set of observations. We don't want to try to design experiments to test the entire model. We want a smaller piece that we can come up with good, testable hypothesis. And again, this model is some simplified conceptual picture to explain this natural observations that we don't understand. From there, now we have this sort of conceptual diagram to explain what we're observing. We have to design a series of experiments that will test our hypothesis and the larger model. So we're going to design experiments, run those experiments. During the experiments, we make, again, some more careful, detailed observations. And at that point, we go, did that experiment we ran, collected certain observations, did that help us answer the question we had? And if so, that's a good experiment. And then we look at the broader model. Does this new set of observations under this testable procedure help further enhance or disprove our model? If the observations were made in this careful experiment disprove the model, we get rid of it and come up with a new model. If the experiments we ran gave us observations that support the model, then we refine our hypothesis to add some more detail to this overall model. So we're continually going through this sort of cyclical process where we're taking our model, some simple conceptual understanding of the process, designing experiments to test portions of that model, make observations, and then come back to our original question and ask, did our new observations fit into the larger model? If we continue to do this and get a lot better and better picture of the model, then that model gets to be transformed into what we call a scientific law. It's sort of a basic understanding that's supported by a vast amount of experimental data and observations to show that that model is good. We can never go about in science to prove anything. We just it's supported by a vast amount of data, and that's the best we can do. There sure is still experiments we can run on all of our so-called scientific laws, but they've stood up to observation and experiments. That's why we've considered them a law. Everything else we're talking about is a model. So in the scientific method, we're continuously running through this process, and we're going to do it primarily in the lab, but we'll also sort of observe our understanding or our process through chemistry through this model.